Good morning. We're going to be talking about probability models and specifically looking at z-scores. Okay, make that just a smidge smaller so I have some room here. Okay, so we have some vocab to start off with that we need to talk about. We need to talk about an expected value first. This is the mean of the probability model. It's very, very simple to calculate. I'm just going to go right into an actual example with this. Bear with me as I am doing this on my touch screen. So we're going to have a table here, if it'll let me. I'm going to have X, so I'm going to have 10, 20, and 30. And then my probability of getting a 10 is going to be 0.5. My probability of getting a 20 is 0.3. Probability of a 30 is 0.2. Now, obviously, if we're talking about a probability, that probability has to equal 100%, so those probabilities have to add up to 1. In this case, they do. In order to calculate how to get that expected value, here's what you do. You take your value of X times that probability percentage plus, and you just go all the way through that table until you get to the end, and then you actually just calculate what it is. So I would just go ahead and calculate this, and I would get 17. So based on this, the expected value looking at this probability set is going to be 17. Not that bad. Another thing that they're going to ask you for, and this is the kind of the meat of our lesson here, is a z-score. Okay, a z-score measures the distance from the mean in standard deviation units. So here's why this is important. When we talked about a normal distribution curve, we talked about those percentages in terms of being 1 standard deviation away, 2 standard deviations away, 3 standard deviations away. Well, it's not always going to be a perfect, I'm a distance of 1 standard deviation away. Sometimes it might be 1.5 or, 2.25. So this is where those percentiles are going to take place because of our z-scores. There's a couple different things in order to calculate the z-score and figuring out percentiles. We will be using Desmos. I will put those as a link on this lesson so that way you guys can get to those links pretty easily and you won't have to worry about it. Anyway, a z-score. A z-score is calculated by taking x minus your mean over your standard deviation. So x, remember, is the variable. Mu is my mean, and this little guy is the standard deviation. Sorry, very hard to write like this. Hopefully you guys know what I mean by that. Okay, so let's look at an actual example so we kind of get some better clarity and understanding on this. So, a freshman takes a standardized test in which the mean is 125 and the standard deviation equals 15, okay? And this freshman scores a 148. What is the child's percentile? So you guys know when we take our assessments that you get a result and it's like you're in the 20th percentile or 70th percentile, whatever it happens to be. So this is all based on normal distributions and z-scores. And so we're going to figure this out in terms of an actual situation that actually occurs. So the first thing we want to do is we want to calculate that z-score. Okay, and that's not that bad. We just use that formula that we had on that last page. So z is going to equal, my variable, this child actually scores a 148, so that's my x. My mean is that 125, and the standard deviation is 15. So I just need to calculate this. I get 23 over 15, approximately 1.533. Okay, great. That's my z-score. Now what? So here's where Desmos comes into play, in which you need to use Desmos to figure out what this is going to do. And this is the reason why I like this is it really does a great job of showing you what a z-score actually represents. So if you notice here, looking at this normal distribution curve, this bell curve, I have a blue shaded region. That's giving me the left here is that -2, the B is the 0.6. So that's telling me this number here is that 70% of that data lies within that blue region. Okay, so this is why I like this. It kind of gives you a graphical and it gives you a visualization for this. So here's how we're going to use this. We want to know the child's percentile. We know that the upper bound, aka the B here, is at 1.533. Okay. Because we're looking for a percentile, we don't want to use -2 because if you notice, we still have a little bit here. We're going to change this to be a little bit more extreme. And I say extreme because I go to -10. Remember, being 10 standard deviations away from the mean is very, very slim. So that's why we don't really need a lower bound, but in this problem or this calculator on Desmos here, you need a bound. So that's why I just went with -10. So if we look down here, we see then that the percentile is 93.7%. And that again is using that Desmos calculator. Okay, so now we're going to switch gears a little bit. Now instead we're going to go the reverse way. We're going to have the percentage and we're going to have to figure out the z-score. And there is a calculator, a Desmos calculator, a different one, in order to calculate that. So find the z-score for the regions. And I have a couple different examples here. So for part A, we're going to find the top 10%. For part B, we're going to find the middle 60%. Okay, so when we're talking about the top 10%, realistically, we're going, that top 10% would be at 90%. So we want 90% down. Okay, so we're going to go to a different one. When you're doing this, you need to notice it says to find the z-score that corresponds to the percentile, enter percentile as a decimal. So we want the top 90%. So I'm just going to put in 0.9 and I get my z-score of 1.282. Oops, not what I wanted. Okay, now when we think about the middle 60%. So if we're thinking about the middle 60%, we're talking 100%. That means on our bell curve, we're talking this region in here. So this and this has to represent 40%. So this is going to be 20% there, and that's going to be 20% there. So what I do is I'm going to just look at this percentage here. Okay, because if I get that down, and then we're talking the middle, right? So this is going to be the negative value, and this is going to be the positive value, everything above it. Okay, so it's going to kind of help me out here. So we're going to go 20%, which gives me negative, which I know is going to be below, but to get that upper half, I then have the positive value of 0.842. So my answer here is plus minus 0.842. Okay. So those those Desmos calculators are going to make or break this for you. Like I said, I will add those links, but that's how we're going to look at those z-scores. And they kind of just tell you, what percentage of the data is here below or in the middle, giving you a range, and that's great. So that's a z-score, and it's all based on a normal distribution.